Now let's wire up the ASP.NET Core API to work with the author data. There will be a bunch of steps to follow, but we'll start by creating a controller to interact with authors by way of the pub context. That means the new project needs a reference to the domain project and the data project. Once we've done that, we can go ahead and add a new controller. You can do this easily in Visual Studio by right-clicking the Controllers folder, then Add, and then choose Controller. You'll be presented with a few options for how the controller can be structured. And what we want is in the category of API controllers, an API controller with actions using Entity Framework. As part of the workflow, Visual Studio now asks us to identify which model and which DB context class to use. So that will be author for the model class and pub context for the DB context. And I'll leave the default controller name as author's controller. Now the template performs all of its magic when you click Add. Visual Studio will add a number of packages to the project, some for EF Core, some for code generation, and some for logging. Once all those changes have been made, then the template will continue by building a controller class that has actions to retrieve, add, update, and delete author objects. First, let's take a look at what happened to the CS_proj file. There's a lot more in there now. There's a package reference for EF Core SQL Server. Then there's the tools package in case I want to run any more migrations. And remember, I had that in the console project in the other solutions. The code generation package was used by the project to build the code for the controller. And also there's the project references. Those got added when I referenced the projects earlier. There is one change I do want to make here, though. Currently, EF Core is on version 6.0.2. That .2 represents a patch version, and I like to replace that with an asterisk so that as patches get released, and I don't mean minor versions, which is the 0, or certainly not major versions, which would be EF Core 7, I want my app to stay up to date. So I'll replace the 2 with an asterisk. I want to forewarn you that while the template-generated code is a stake in the ground, it reflects a bit of an anti-pattern by sending the domain objects retrieved using EF Core back to the caller. But for now, we'll work with the controller as is, just enough to get it running, and then I'll show you how to do a small refactor that will make the controller work more closely to how most ASP.NET developers prefer to use it. I'll scroll through the controller class quickly, and we'll learn more details about what these methods do while we're debugging them and while we're doing some of the refactoring. First, you can see there's a constructor that references the pub context, then a get method to retrieve all the authors, and another get method to retrieve just one author using its ID. There's a put rest method for updating an author, a post for adding a new one, and a delete method to, you guessed it, delete an author from the database. This last little method is just a helper method that's used by the put method's error handling. And notice that the methods for executing queries are all async. And in the methods for persisting data, it's using save changes async. Using async methods in the web app is important so that the user interface doesn't get blocked while waiting for EF Core to finish its interaction with the database. With the controller added to the ASP.NET Core app, it's time to wire up the ASP.NET Core app with a DB context. We need to let it know about the DB context, and that's done by configuring services in the program class. ASP.NET Core uses dependency injection, often referred to as DI, to interact with other features, including EF Core. The dependency injection is managed through ASP.NET Core's services, and we create a different service to manage each of these different features we want the application to interact with. If you're new to dependency injection, don't worry. ASP.NET Core will take care of the hard part. You just have to connect a few dots, which is what we're doing here. And hopefully, after this explanation, you'll have a better understanding of it. There's a whole course on dependency injection in C# by Henry Bean, which I'll link to in the resources slide for this module. We'll add a service to manage the pub context, which is easy thanks to an extension method provided by Entity Framework. I'll start with the Builder Services collection, following the examples already in the class, and then add DB context. That's the extension method. And the method is generic, so we then have to say that it's for the pub context class in the publisher data namespace. The add DB context method expects a lambda to describe the DB context options. So in the parameter, I'll name the lambda variable opt, OPT. Then there's the lambda operator, and now the opt variable lets me apply some methods. We've seen DB context options before. That's how we configured the database provider, the connection string, and more in the DB context. But all of that's going to happen in the program file now because the service will be responsible for instantiating the DB context for us. Just like we did with the options in the context file, I first need the use SQL Server method. And I'm using the control.key combination to let Visual Studio add the EF Core namespace. Then I need the connection string, and I'm sticking a placeholder there for the connection string. I also want to enable sensitive data in the logging. But notice I'm not going to add the logging method that we used earlier because logging is built into ASP.NET Core, so that's helpful. There's one last thing I'll do here. Remember, the DB context options has a method called use query tracking behavior. So I'll just define no tracking for this context right here in the service. That means the context used by the controller will default to no tracking queries. And the controller that was generated by the template has no code that relies on tracking anyway. So this will help improve performance because the context won't waste any time needlessly tracking the objects that it queries. Rather than hard-coding the connection string, I'll put it into the app settings file. And at the same time, I'm going to specify the EF Core logging information that I want to be output. This is a JSON format file, and it already has some default configuration set up for logging. So I've just added in a section for connection string with one named pub connects, and its value is the same connection string we've been using all along for the pub database. But I also added something to the logging section. Does it look familiar? It's the same setup we used earlier, but expressed in a much easier way as a configuration. I've specified that along with the default logging information, the logs should also output the SQL commands generated by EF Core, and the log level, like before, should just be information. What I'm not telling it here is where to output the logs. By default, ASP.NET Core is set up to output to console, debug, and a few other places. So I'll show you two ways you can see the logs when it's time to debug. But we still have a few more steps to do this wiring up. And the very next one is that I need to return to the program class and replace my connection string placeholder so that it can find the connection string I just added into the app settings file. And I've done that by saying to read the builder configuration. Then configuration has a get connection string method. And as its parameter, I've passed in the name of the string that I defined, which is pub connection. If this is the first time you've done this wiring up between ASP.NET Core and EF Core, it may seem like a lot of steps. But once you've done it a few times, it just feels routine. So I hope you'll trust me on that. And the bad news is we're still not quite done yet. The last stop is in the pub context file. We're going to add a constructor that can work with the dependency injection that we just defined in the program class. And then we'll just do a little cleanup. First, I should probably show you why we need another constructor in the DB context. The controller uses a pub context instance, and it expects this instance to be passed into its constructor. The controller isn't going to just instantiate the DB context, and that's because it's using a software concept called loose coupling to make your software more flexible. You can learn more about loose coupling in Steve Smith's Solid Principles for C# Developers course. This means that whatever instantiates the controller needs to instantiate the DB context first. The ASP.NET Core app will instantiate the controller internally. It also doesn't have explicit code to instantiate a new pub context. This is where the dependency injection kicks in. What we did when defining that service was tell the ASP.NET Core app, Hey, anytime you find a constructor that expects an instance of pub context but you don't have one, go ahead and create it on the fly and use these options. There's only one problem. The pub context doesn't have a constructor that takes in the DB context options, and that's what we'll create now. I've added this new constructor into the pub context that's defined to accept and use the DB context options. First, by specifying that it should take in a parameter, and the parameter is a DB context options of pub context. I'll give it the variable name options. The internal DB context class already has a constructor like this, so I'll add here that it should do with options whatever the base class's matching constructor already knows how to do with the options. Now the ASP.NET Core app will be able to instantiate a pub context, pass in the options we defined in startup, then pass the resulting object into the controller. So the last little bit of work here is to do my favorite type of coding, which is to delete code. Since all of the context configuration information is now specified in the startup file and the app settings, and the logging is built into ASP.NET Core, I can remove the entire onConfiguring method, and then you can also clean up the using statements that aren't needed any longer. So that's it. Finally, the ASP.NET Core app now knows how to work with the pub context and the pub database, as well as include the SQL commands in the logs. And we have a controller that will let us use EF Core and the context to interact with author objects.